Hi, folks. So today is our final lecture for the entire semester, and we've been looking at the Drake equation all along, all the different little pieces that go together that tell us how many communicating intelligent alien civilizations we think are out there in the galaxy today. The very last one is L, the lifetime of civilizations, and this is measured in years. So how many years you think one civilization would actually last? And we don't know yet because our civilization hasn't collapsed yet. But even though this may be one of the things we know the least about, it's arguably one of the most important for you yourself personally, and also for your kids and everything else that's going on in our society. So we're going to look at some of the different ways that a civilization might actually end, both through itself and naturally. So all right, so make sure that you've got your class notes out. This is Tool 30, our final tool for the semester, Lifetime of Civilizations. If you haven't got it out yet, go ahead and pause the video, get that up where you can follow along. So basically, when we're talking about the lifetime of civilizations, we're talking about Doomsday. How is the world going to end? So here we've got an example of a collision with another astronomical body. This actually, we think, is how the moon formed. So there was a Doomsday in the past. There just weren't any humans around to look at it. But keep in mind, all things die. Stars die, planets die, life forms on those planets die, and entire civilizations die. So the real question is, what is the lifespan of a civilization? We have a good idea for stars, planets, and life forms, but we've only really got one civilization that we can compare to. So nobody knows how long they can survive. And there's really kind of two perspectives here. If you are an optimist, then you follow the Star Trek model that technology can solve all our problems. In Star Trek, the whole idea is that they've got these replicators that can make anything, food or items or whatever, so you no longer need money. Everybody's got everything they could possibly want, and we use technology then to solve all of our issues. The other possibility, the probably more pessimistic way, is that the first thing somebody does whenever a civilization develops advanced technology is they find better ways to kill each other. And so eventually, maybe they find a way that they can actually destroy the planet and they end themselves on that planet. So this is a thermonuclear explosion. This is an actual picture, by the way. If you had asked me 10 years ago, how is our civilization going to end? I would have said most likely through nuclear war. We're probably going to launch weapons at each other. We've got enough weapons on this planet to kill each other roughly 8 to 10 times over. So currently, today, there are 3,750 active nuclear warheads pointed at each other. We have another a little over 10,000 on standby. And so if we launch these, obviously we're going to bring the next ones on standby. Each nuclear weapon could basically vaporize an entire city. So basically, if you launch one at New York City, the entire island of Manhattan will vanish. And in tests, we've actually done this, where they did some islands out in the South Pacific, and they detonated a nuclear weapon there, and the entire island vanished. So this is not just hypothetical. It does not take more than about 10 to 20 of these to basically make Earth uninhabitable. So with this many nuclear warheads, we're not just dead, we're most dead. And the idea is that if we have this many weapons pointed at the Russians, then they've got this many pointed at us, then it's called mutually assured destruction, MAD, MADD. And so therefore, neither side will ever launch their weapons. Well, the problem with that whole strategy is that it assumes the other side doesn't actually want to die. So if you, in this era of suicide bombing and things like that, it would be very easy to start this chain and start a nuclear war that would basically wipe everybody off the planet. Now, this is an improvement, though, because in 1986, we had 70,000 active warheads pointed at each other. Now, through treaty, we brought it down to 3,750. The United States actually stepped away from that treaty over the last 4 years. And so in response, Russia has actually been increasing the number of their nuclear warheads as well. So we're actually a little more unstable than we were 3 or 4 years ago. But another possibility is that we could have an asteroid impact. Now, this has happened at least 5 to 6 times in our Earth's history. The last major one was about 65 million years ago. This is the one that took out the dinosaurs. It impacted in the Yucatan Peninsula in Mexico, off the coast of the Gulf of Mexico there. And basically, this wiped out about 60 to 90% of all species on the planet. So the fires, moved up through North America. All of North America was basically set on fire. All that soot and smoke went into the atmosphere. And essentially the food chain crashed because we didn't have any sunlight coming in. All the plants died. All the animals that ate the plants died. And then the animals that ate the animals that ate the plants died. And there weren't very many things left, except one of the major species that was left were these little furry creatures called mammals that lived in the rivers and ate dead things. Well, there were lots of dead things for them to eat, so they were able to thrive. The next major possible impact is Asteroid Impact. It's last I heard there was about a 3% chance of it hitting us in 2029. This one's a dinosaur killer. If this one hits us, it's going to wipe out all life on this planet. Now, just a few months ago, there was an update. They are pretty sure that it's going to miss us, that it's not going to be a problem, but it's still basically a non-zero chance. And if this thing's coming at us at this point, there's nothing we can do. There's nothing we can do to stop it. The world is just simply going to end. But if you ask me today what I think we are most likely going to kill the planet, and that's going to be with global warming, with climate change. And we're already seeing this happen. We're seeing the effects of moving towards actually in-stage global warming already. And you guys know how the greenhouse effect works, but as the carbon dioxide levels in the atmosphere increases, that increases the global temperature. Most of that heat goes into melting the ice caps. That's actually what's keeping our temperature from rising any more than it is already. But once those polar caps are gone, everything goes directly into the oceans. All that moisture rises up into the atmosphere. And as you know from the inorganic carbon cycle, we're going to start to get these storms that are coming down. And so even though Earth may actually end up like Venus, we probably won't be around to experience it because these superstorms are going to basically destroy our civilization. I mean, you think how bad a single hurricane can be. Now imagine that you're having superstorms basically 24/7 over the entire planet. So since that's the most likely scenario, let's actually look at what's happened. This is a map of the coastlines around Florida. We've talked about how some of this works, but the greenhouse effect then is melting those ice caps. As those ice caps melt, that's raising sea level. And we're already having to evacuate points in Key West because the islands that they're on are basically underwater at this point. And again, as I said, once the ice caps are gone, that goes directly into the oceans. This is actually getting even worse than we thought because as the permafrost is starting to melt, that's actually releasing carbon dioxide that was trapped in the permafrost. So not only is the rate increasing, but the rate at which it's increasing is increasing. So we are currently barreling down towards basically making the planet uninhabitable. And to give you some more examples of here, this is tracking glaciers. This is one of the earliest signs that you'll find that global warming is occurring. And so this is Greenland. This is where the ice was in 1979. This was how far it had retreated in 2007. Got some pictures here that you can see. This is the Uppsala Glacier in Argentina, and this is today. This was, if I recall, I believe this was like 1908. But you can see that the glacier extends all the way to the coastline. But then today, it's actually retreated all the way back up the mountain to here, and this is just basically a lake. This is Norway in 1928. And this is the same area today. So just moving back and forth between, you see the mountain in the background there. That's what we see. And so basically the entire glacier has melted, and that's what's formed this glacier lake that we've got right here. This is the Rhone Glacier in Switzerland, and it came all the way down to the town in 1859. This back now in 2001 is retreated back up the mountainside. A little more recently, this is Kilimanjaro, one of the tallest mountains in East Africa. This is in 1992, and this is in 2005. So you see that this problem is becoming more and more widespread. Even in the United States, we're starting to see this. This is Mount Hood in Oregon in 1985. You can see that these are all glaciers. This is not snow that's fallen on it. These are glaciers. They're supposed to be permanent. They're supposed to be year-round. They stay all the time. And this is what Mount Hood looks like. It says 1985. This is actually the 2002 picture from there. So as we lose the polar ice, then that ice is raising sea levels, as we see. And we can see that this is increasing over time, starting at about 1900. Prior to 1900, it was reasonably flat. That's what this line right here is showing. And then from 1900 to about 2000, we're seeing this increase. Another case, this was actually just recently. This couple traveled to the North Pole, kind of adventure travel sort of thing, and they left this time capsule that you see here on the North Pole in 2018. The ice had melted to the point where the flows had carried it down that it was actually found on the coast of Ireland just this in 2020. So the ice pack is already melting quite a bit from that. And if there was any doubt that CO2 is linked to temperature, of course, we already know that because we know how the inorganic carbon cycle works. But we can actually look at tree rings and ice cores. Those preserve the amount of carbon dioxide over thousands of years. So we can look at the amount of carbon dioxide in the atmosphere all the way back to about 1000 AD. And we see that increases starting again about 1850, 1900, and then peaks dramatically at this point. And there is a one-to-one relationship between the carbon dioxide levels, which is the blue line, or which is the red line, and the average temperature lines, which is the blue that you see here. So around 1900, something changed. Well, the obvious thing is that was the start of the Industrial Revolution. And if you think about pictures, if you've ever seen pictures around 1900 of London and things like that, with the smoke just billowing out of all the factories and that sort of thing, that's when all this basically started. So as we mentioned, the temperatures aren't just increasing, the rate at which temperatures are increasing is increasing. And there's people who say, oh, well, there was this medieval warming period. Well, that actually, if you look at the global temperatures, that was actually just a local occurrence that happened from about 1000 to 1200 AD. And globally, the temperatures were actually decreasing. The Little Ice Age, they said, oh, well, this has happened before. Well, this was just the end of a slight downturn. And so now we've actually been coming up from that. So you see that was that slight downturn, that continuous coming down period that ended right around 1700. And then at 1900, all of a sudden the temperature started increasing again. So the question is, did humans cause it? Now, you guys know my opinion on that. Who cares? If humans caused it, fine. If humans didn't cause it, fine. But if humans can fix it, why wouldn't you? But knowing what caused the increase maybe will give us some clues as to how we can go about fixing it. So we've got three models here, or two models in the observations. The red model here includes the data with human-caused sources. So basically the Industrial Revolution, fossil fuels, that sort of thing. The blue model is without human causes. And you see that the only one that fits, starting around 1950, is the one with human-caused sources. So, like I said, do you care? No, probably not. This happened long before most of you were born, but if you can fix it, why wouldn't you? If you don't fix it, you're all going to die. So it's kind of up to you. So things to look for that indicate that we are nearing the end stage of climate change and the end of our civilization. So we should have exponentially rising global temperature averages. Well, check. Decrease in the size of polar caps. Check. Rising sea levels. Check. Increased acid rain. And that, think back to what we know about the inorganic carbon cycle. Remember that as the atmosphere heats up, that causes the water vapor in the oceans to rise. That rains out in these storms. Well, the rainwater plus the carbon dioxide forms carbonic acid, and so that's acid rains. That's another thing that we can measure. Check. Superstorms. Check. Increased frequency and severity of hurricanes. Check. And all of this while we still have most of our polar caps. And if you do the math and you extrapolate out just linearly even, you find that the polar caps are probably going to be gone starting in about 2070. After that, things kind of go to hell in a handbasket pretty quick, because now all that heat's going directly into the oceans instead of melting the polar caps. So there is a good chance then that this is basically going to be the end. My generation has failed you guys. It's up to you to decide what you want to do about it. At this point, we're basically trying to cut down carbon emissions just to tread water. Cutting down carbon emissions, eliminating carbon emissions at this point is not going to be enough. That's not going to be enough to reverse the trend and bring us back down to the safe levels. At this point, we need some sort of a technological solution, and nobody really even knows what that could be. So the push towards green energy is absolutely essential, but it's really just to buy us time from that. So when we're looking at alien civilizations, Fermi, who is a physicist, proposed this paradox. He said, okay, let's assume that 1 in a million stars, generates a civilization. And, he's basically using the Drake equation and just kind of coming up with some estimates from that. That would mean that there are about 100,000 civilizations in the galaxy because there's about 100 billion stars out there. So all of these would have formed within the past 5 billion years. If you think about how long it takes for stars to form, the galaxy is about 14 billion years old, things like that. So if they are evenly distributed out, then the next youngest civilization would be about 50,000 years old. So they should be much more technologically advanced than we are. So surely they figured out how to solve the issue of colonizing all of these stars. Even if we can't travel faster than light necessarily, but even if we're using generation ships, they should be able to do it. So the Fermis Paradox is, where are they? Why are they not already here? And the key here, if you think about it, if you've got your home system here and you send out one ship here and one ship here, so these two colonize, they then send out two, and they send out two, and so on and so on. The entire galaxy should be colonized in fairly short order. It should already be colonized. So there are some possible solutions to Fermi's paradox. One is we're alone. There isn't actually anybody else in the galaxy. It's just us. Now, out of 100 billion stars, many of them with habitable planets, that seems pretty unlikely, but it is one possibility. The other possibility is that civilizations are common, but they either don't live long enough or never develop the ability to explore. We may actually kill ourselves before we develop the ability to colonize another planet. Maybe that's common. Maybe that happens all the time. And so that would explain why we don't currently have any civilizations just basically taking over the galaxy right now. The other possibility is there is a galactic civilization and some combination of, the Federation's prime directive where they don't interfere with other civilizations that haven't yet developed interstellar travel or whatever. They're watching us. They know we're here, but they're intentionally hiding from us. So that's a possibility as well. So if we want to figure out how many alien civilizations are communicating in the galaxy today, we use the Drake equation. We did this on the very first day of class. So now, based on everything that you've done up to this point, let's figure out how many civilizations you think there are. So N, remember, is the number of communicating alien civilizations in the galaxy. This is what we're looking for. RS is the rate of star formation. So conservatively, you might say about 1 star per year in the entire galaxy is being formed. Optimistically, maybe about 20 stars per year. Remember, it can take several million years for a star to form. So pause the video. You write down how many stars per year you think are being born in the galaxy. So did you pause the video? If not, you're cheating. Pause the video. Okay, you got your answer? All right, NASA estimates about 7 stars per year, but remember, all these change from year to year, so your estimate is as good as NASA's from that, so definitely go with yours. FP is what fraction of stars have planets, so what percentage of stars have planets. If you think all stars have planets, then you would, 100% of them, you choose 1. If you think half the stars out there have planets, you choose 0.5. If you choose no stars have planets, including the one that you happen to be standing on, then you choose 0. So pause the video, come up with a fraction between 0 and 1, a decimal. Okay, you got it? Now NASA actually blends this one in with the next one. So how many habitable planets do you think are in the star system? So we've got a star system, it's got planets. How many of those planets do you think are habitable? It could be anywhere from none of them, including Earth, to 100 of them. Now, we think, obviously, that Mars and Venus were habitable at one time, even though they're not habitable now. Titan, which is a moon of Saturn, has an atmosphere. It's actually thicker than Earth's, so it's entirely possible that it's habitable. Europa, we think, has an ocean underneath. It's a moon of Jupiter. We think there's an ocean underneath there that could be supporting life as well. So beyond just planets, some of the moons of the larger planets might also support life. So how many planets in our solar system do you think could support life? Pause the video, write down your answer. All right, ready for the next one? Now, NASA estimates the product of these two, multiplying these two together, is about 0.2. So that means about 20% of all the planets, all the stars out there, have a habitable world. That's just based on the number of planets that we've seen so far, but remember that we can only detect planets if if their solar system is edge on to us. We can't really see them if they're this way. So it's probably almost certainly higher than what NASA is estimating here. Of those planets that are habitable, how many of them actually develop life? We don't know how life starts. How does life make that magic jump from chemistry to biology at that point? At what point does it cease to be just random chemical reactions? And what point does it become alive? We don't know how this works. But if you think that life is very rare, you have to have specific conditions for it to happen, even if the planet itself is habitable, then you're going to choose something close to zero. On the other hand, our experience on Earth has been where there's water, life seems to find a way, even when in areas that we didn't think life could exist. If that's what you think as well, then you're going to choose something closer to 1. Statistical measurements say that it's probably greater than 0.13. Other than that, we really don't know. So that means anywhere from 0.13 all the way up to 1 is what NASA is getting. Now, let's suppose that the planet has life. What percentage of those planets will develop intelligent life? And so far, there's only really 2 intelligent species on this planet. That's us and the dolphins. So if you think, though, that intelligence is a survival trait, that natural selection is going to always cause intelligence to develop because they're going to dominate, that's the reason why humans dominate the planet, then you're going to choose something pretty close to 1. On the other hand, if you're not sure there's any intelligent life on Earth right now, then you're going to choose something that's maybe closer to 0. NASA has absolutely no idea. We don't have enough data points to even decide. Now, assuming that there's intelligent life on the planet, so we're assuming there is an intelligent life form here, what percentage of them will actually develop the means to talk to us? So, for example, if dolphins had been the only intelligent species on this planet, we'd never know it because dolphins are never going to develop technology able to communicate. So if you think that if they're smart and they're intelligent, of course they're going to develop technology eventually, then you're going to choose something close to 1. On the other hand, if you think that, most of them are just going to be happy swimming around in their ocean, then you're going to choose something closer to 0. And again, NASA has absolutely no clue. Then this is the last one that we talked about. How long do civilizations live? They could live anywhere from 10 years to 1 billion years, depending upon what you think. I mean, the Roman Empire lasted 1,000 years, but obviously humans were still here. So you would have to decide. Kind of depends on how pessimistic you are. So pause the video, decide how long do you think these life forms are going to live. All right, once you have all of that, multiply all of those numbers together and figure out what your value for n is. So pause the video and do that right now. Okay, so you got your answer. So these numbers are going to vary pretty widely. They could vary. I've had students get everywhere from 1, which means we're alone, to as many as 100 million in the galaxy. So it depends pretty heavily on what numbers you choose, and everywhere from FL onward is kind of unknown. So these are some of the areas that the astrobiologists and the sociologists are looking at right now, trying to pin down these numbers. The first 3 are astronomy, and we do pretty good with that. We've got a pretty good idea of what these are. But these 4 get increasingly more unknown the more you move over towards the right here. However, if you got a number bigger than 1, you have just proven that we are not alone, that there is at least one other alien civilization in the galaxy that's just like you, that's able to communicate with you, that's looking, you look out in the night sky and you're looking at those stars, there's somebody out there who's actually looking at you back. And with that, we finish the semester. This is everything that I'm going to be teaching you. Go ahead and download the practice worksheet, work that out. You've done basically everything that you need for that. That'll be graded for accuracy as always. So take a look, make sure that you've got everything together, make sure that you've got all 30 tools together so that you're ready for your final, so that you can have it easy access, make sure you're organized, and you'll be able to get started on your final project. Okay, guys, that's it. With that, I have taught you all that I'm going to teach you. So the course is at an end. Hope that you found it interesting. Obviously, you still have your project to do. You're here. Your next big task is to take that star field with 500 stars in it, find that habitable world. Once you've found the habitable world, understand, figure out all of its characteristics, and see if you can figure out what the aliens on that world would look like. At this point, you are as qualified as anybody at NASA. I would be able to drop you down at the telescopes up at GCC North, and you have everything you need to actually search for aliens in real time. Hope you've enjoyed it. Hope you've learned a lot. Stay in touch. Come by and see me anytime. Drop by and just say hi. I always like to hear how the students are doing. So you guys take care.